Grade 8, this is a review of section 1.3 in our textbook regarding scientific notation. So scientific notation is, as we mentioned earlier in class, it's when we take a look at big numbers and we try to condense them into smaller numbers using the help of tens and their exponents. Okay, so we'll take a look at understand how to use scientific notation. Very quickly, if I use 456, where is the decimal? The decimal is, oh, did I do anything here? No, that's, oops, okay. Anyways, the decimal is right here. It's unseen for the most part. So anytime you see a whole number, we usually don't write the decimal. It's after the number, okay? We use this decimal when we use scientific notation. If I were to move this decimal to the left, I could just say that that's going to be 45.6, but I want to bring it back to its value, 456, so all I would do is multiply it by 10. So if I move the decimal over, 45.6 times 10 is the same thing as 456. So by me effectively writing this number here, I haven't changed anything to the value of 456, and this is an important principle when we are looking at scientific notation. Typically in my class, I'm going to get you guys to take your decimal and put it after our first number and round to the hundredth, which is two numbers after the decimal. So if I had 4.56, I mean, that's the same thing as me saying 4.56 times 100, so that the value is still 456. And what I could do right now with this 100 is I can actually use tens, powers, and tens. So 100 is just 10 squared. So 456 just became 4.56 times 10 squared. Now I know what you're thinking, Mr. Panus, this is actually a lot more work just to write this small number 456. However, we don't use it really on these small numbers. We use it on much bigger numbers. Okay, and that's just a review. So let's take a look at the distance from Earth to the Sun. The distance from Earth to the Sun is 150 million kilometers. That's a lot of numbers to throw around, and if we were talking about in centimeters or millimeters, that number would get even bigger. So if we were to use scientific notation, what we're going to do is we're going to take 150 million, we're going to take this decimal, and we're going to move it all the way from where it was to the first number. So we would have 1.50, and we would actually have to count how many decimal places we've moved it. So we moved it 3 spots here, plus another 6, plus 7, plus 8. So that means if I were to use this, it would actually be times 10 to the power of 8. So 1.50 times 10 to the power of 8 would equal 150 million. In the end, we usually cut down the number so it's to the hundredth, like I had mentioned. And when you do that, you have to look at your number before this. So I'm looking at this number. If this number is a 5 or higher, oh, this shouldn't be, sorry, 1 second. If this number is 5 or higher, then we would round this number up. So in this example, sorry guys. In this example, I would just pretty much use 1.49. I'm going to change this. So this is a little bit wrong, 1.49. Okay, sweet. So it would be 1.49 times 10 to the power of 8. Okay? Sorry about that. And that's pretty much it. That's pretty much what scientific notation is. So again, we're going to take the number from wherever it is, bring it to, or sorry, take the decimal from wherever it is, bring it to the first number after the decimal, and then round to the hundredth. All right. We'll go over some more examples in class just so that you have a really good understanding of this.